Okay, couple things new. One is I put a USB connector here so I can power this thing off of a micro USB. And that way I can run around with a power bank and run this thing remotely, which I did the other day. I took it to lunch with my friends and brought it along battery powered, so they liked it. I've changed my program a little bit. Currently the program reads the switches and puts it in register A, reads the switches, puts it in register B, takes the output of the ALU and puts it into the I/O register, and then it increments the program counter. So you can see it counting here, so the program counter is whacking away. And then I added another instruction that says take the program counter and move it into the RAM address. And that's not working. These two should be mirrored. This should be counting as well. I noticed that if I look at the RAM address line, if I pull that loose, you can see this flashing now. It's just picking up noise in the system, so it's just pulsing that line because it's kind of picking up 60 hertz or clock noise or whatever. And so if I kind of grab it, I'm 60 hertz, and I can get it to flash this. So that tells me that the the to RAM address line isn't working. Because when I hook it back up, it's hard to do with fat fingers. Oh, come on. I should have tweezers or something here. There we go. It doesn't do anything. So, and then after it increments the program counter and copies it to the memory address, I'm having it read memory and write it to the output. So if there's any random data in memory, I should see it here. And it's flashing a bit, so maybe maybe there is something in memory. Remember, one of the writes from here is the output, which is 0, and one of them is from RAM. So the BF, looks like there's a BF maybe, and then a 00 that are talking back and forth. That, I think it's actually reading from RAM, but the memory address isn't working right. So let's go take a look at the schematic, see if I did something stupid, or maybe there's a solder bridge or something. But first thing to do is check out the PC board to make sure it's designed right and wired right. All right, so here's the microcode machine, and there are two devices and from devices, so we're trying to do a to RAM address. So that's this pin here, so that's where I have it. And that is routed to a 7404. So let's take a look at the schematic. RAM address right. So that's this one. So yes, pin 3 and pin 4. Pin 3 comes from the 2s. So I should be, see, RAM address is, RAM address is pin 3, which is 012. So 012. All right. So, oops, not where I wanted to look. Let me look here for a second. That's not where I wanted to go. That's not where I wanted to go. I wanted to take a look at the program. I think I'm going to have to open that up. Make sure that we have the assembler working correctly. So I don't know if you can read this. I can't change the font size on this, so it is what it is. So we have from RAM address is 002 and to RAM address is 02.
20. Oh, that's not right, is it? No, that's not right. Oh, yes, it is. I forgot. It's high byte or high nibble, low nibble. So the high nibble is the 2. So 0, 1, 2. Okay, so 2 RAM address. So that's right. So it should have compiled correctly. All right, so for some reason, the PC board isn't outputting. Oh, the other thing that we need to take a look at is the ROM RAM board, because that's a brand new design. And that's the one I did in a hurry. So let's take a look at that. Let's open up. Is it this one? Yeah, it was this one. Do you want to? Yes. Okay, so this over here on the right is the ROM RAM board. And let's open up the schematic for that. So this is the ROM RAM. And here's the latch. And RAM address right is what we're doing, goes into pin 11. So that looks right. Let's see if it's laid out correctly. So pin 11 should come out to RAM address right. Pin 11. Oh, here is, it looks right. Looks like a very easy layout. Here up to address. Here's a RAM write and there RAM read, but here's RAM address write going to pin 11. So that looks okay. Okay, so I think we get out the oscilloscope or the logic probe and take a look at what's going on.
All right, we're running, and I've connected a wire to RAM address right, see if there's anything live there. And here is the scope, so we do have a positive going pulse, so that's correct. So the inverter's working and the logic's working and everything, so we have to figure out if the timing is correct. I don't see why it wouldn't be. So maybe there's something wrong somewhere else. We could, instead of writing to the RAM address, we could just set up a can't find the words today. A register, just a simple register, and see if we can write to a register. So see if that line is actually working correctly. So I've slowed the clock way down so I can watch the bus. This is the bus, and we have the switches set to E2. This is E2, so we can watch the bus get asserted right now. You saw a flash. That was the read switches right to register A, read switch right to register B. So that's going to assert this onto the bus twice. So we see the EE, EE, then we see some other funny things going on. EE, flash 1, flash, Alright, so if we go over here to the program counter, oh, it's all kind of lit up now, it's kind of hard to see, there we go. So we can watch it count, and we should be able to see this particular value get asserted onto the bus, and I never see that happen. So there's something strange about reading the program counter. So maybe that's it. We can't put the program counter onto the bus. So I need to figure out why that is. There's The program counter has a couple pins on it. It has a clear, which we're not using, a read, write, and an increment. So the increment is obviously working because it counts, and the, let's see here, the write is set to a program counter 2, we're not using that, and the read is this one, set to, oh, no, that's right, set to PC read. I thought it was off by one. Program counter read. Oh, maybe it wasn't making good contact. Now we have a C1. Oh no, well, maybe it's working now. Ah, maybe it was just a loose connection. Let's speed up the clock. You know, laying out PC boards was supposed to eliminate all of that funny business going on. Yeah, there we go. We have C. Oh, well, it's almost working. We're only getting one count now. It came over once, but not again. Oh, that's because I don't have this one connected, which is the RAM address. Forgot. I had that hooked to the oscilloscope. Let's put that back on. Nope, that's not working either. Well, crud. I thought we had it. Let's slow it back down again. Oop, I think it's speeding it up. There we go. Flash, flash. No, there's something funny going on. Now, why did it almost work? What did I do? I had PC read. It is incrementing, but it's not getting onto the bus. Maybe there's two things being asserted at the same time. Let's pull this off. Oh, that's interesting. I don't know. It's a mystery. We are incrementing this. Let's try putting something into, maybe we'll just write a program that takes the switches and puts them into the RAM address. Let's see if we can accomplish that. That'll be an easy thing to do. All right. Let's see if we can power this up. Oops. I need to. There we go. So, oh, that seems to be working. So now I have the microcode in here. That all it's doing is from switch to address. That's all it's doing. And if I flip a switch, see here, let's speed it up so it'll run fast. It's going too slow right now. Okay. Oh. It's almost working. Let's see, where is the RAM address? Ah, this one. RAM address. I forgot to hook that up. Yeah, it works. So all zeros, and then so we can assert the bus and write it to the correct address. So let's modify our program to whatever address we set will then read memory and put it on the I/O. That'll be a fun program to do. And then we'll have to go back and figure out why the program counter can't assert the bus. Okay, so we have a new microcode. All it does is it reads the switches, puts it into the RAM address, and then the next instruction is take the contents of RAM, pointed to by the RAM address, and put that into our I/O. So we're getting C9. So if I change the switch, interesting. Why is it toggling? Whoa, very strange. Strange behavior. We are getting the address to work correctly, but the contents of the RAM and or ROM is strange. Oh. Contents of the ROM is stable. No, the RAM is stable. Contents of RAM is stable. So if I address 128 or higher, we are talking to RAM. And so we are able to read out RAM, and it doesn't, we're getting random things, but it is stable. And if we read out ROM, it's fluctuating. Interesting. Oh, did I just fix it? Oh, maybe I did. Maybe it just wasn't seated. I pushed down on the ROM chip a little bit. And now we're either getting zeros or FFs, so maybe that's all it was. There's an E2. Interesting. Oh, there we go. Something is funny. So something's loose over here, or the solder joint, or something, but the ROM is a little flaky, it seems. But RAM is nice and solid. Very good. And we're getting various things. So that's good. So we have two things to fix. Program counter can't assert the bus, and the ROM is flaky. I'll have to figure those two things out. I think I'll program something into the ROM so we know what to expect. Yeah, figure out why that's flaky. I don't think you saw any of that, did you? Back that up a bit. I was just pushing on. I was pushing over here. So I was going to the ROM space, and you can see it flicker. And then as I kind of pushed over in this neighborhood, I could get it to fluctuate or not. It looks like something's floating. It looks like a CMOS line is floating. You usually see things like that. But if I go to RAM space, then everything is very, very stable over here. So, okay, there you go.